Hi guys, welcome back to the channel. Jag here, and in today's class we're going to continue with our Math 10 content, and we're going to move on to the next section. Okay, so the next section is graphing the quadratics using the x-intercepts. Okay, in these questions, again, the teacher is just going to give you a trinomial or something like that, whether it's a simple or complex trinomial. You have to make sure you factor it yourself. You have to find the x-intercepts as well as the vertex before you can graph it out. With that, let's get started. Okay, I'm going to put an example on the board here. So let's try this one. So it's y equals x squared plus 5x, okay, plus 6. All right, so I can see here this is a simple trinomial. We are going to show our work one more time here. So the product of the two numbers is this last number, which is 6. And the sum of the two numbers is equal to the middle number, which is 5. One more time, if I'm looking at this quadratic equation, I can see that there are no negative signs here. So I know my factors are also going to be positive. Okay, so let's try 2 times 3, which is equal to 6. And 2 plus 3 is equal to 5. And I can see that both of these conditions are satisfied. So I have my two factors. Okay, one more time, we're going to keep the x squared the same. We are using the decomposition method to break down the 5x into its factors, and we're going to use plus 2x plus 3x and keep the 6 the same, so plus 6. Okay, again, this is the intermediate step. Okay, we're going to do some group factoring. So group the first two terms and group the last two terms together. Okay, all right, so I'm going to take out a common factor between x squared and 2x, which is equal to x. And what I'm left with in the brackets is x plus 2, okay? Then you move on to the next two terms. I have 3x plus 6. I notice I can divide both of these terms by 3, so I'm going to take it outside the bracket. What I'm left with here is from the 3x is the x, and 6 divided by 3, which is equal to 2. Does everyone see that? Every time you take a number out, okay, or a variable, make sure you're just dividing each of the terms by that variable or that term, okay? And always check in this intermediate step to make sure whatever factors you get have to be the same inside the brackets. So my two factors here are going to be what's on the outside. I have x plus 3. So this is one factor. My common factor inside the brackets is x plus 2. Okay? So these are my factors. I'm going to make my equation equal to 0 here, okay? And when you make it equal to 0, the reason for that is I am solving for the x-intercepts, okay? So what we're going to do here, we have some room. So I'm going to do x plus 3 equals 0. And you notice again, the 3 is positive here. You're going to take it to the other side, and x is going to equal to negative 3. Okay, so this is one of my intercepts. Okay, and I'm going to do the same thing on this side as well. So x plus 2 equals 0. Take the 2 to the other side and change the sign. So x is equal to negative 2. Okay, and because the question here says to find the x-intercepts, okay, and we're also going to try the vertex for the parabola for this example, okay. And again, if you're a little confused about how to do the factoring, please check out my last videos. They were basically on finding the x-intercepts of the equations by just factoring the simple and complex trinomials. Okay, so let's try the vertex for this one. I'm going to just take off part of this. Okay, question here. All right, and what you're going to do, so I'm just going to put vertex here. So this is the x point of the vertex, okay? And how you find the x point of the vertex is by adding the intercepts together, and you divide it by 2. Okay, so we're going to do negative 3 plus negative 2 divided by 2. Okay, and the reason that we're dividing it by 2 here is because the parabola is symmetrical on both sides. Okay, so this is equal to, so yeah, it is negative 5, so negative 5, and we are going to divide it by 2. Okay, it's 2.5 negative. For now, we're going to actually just use the decimal form. So I'm just going to put negative 2.5 here. This is the x point of the vertex. So we're still not done here. Okay, when you're looking for the y point of the vertex, you're going to take the negative 2.5 and plug it back into the original equation, okay? So this is actually the original equation at the very beginning. I always make sure I plug it into that equation so there are no mistakes, okay? So it's going to be x squared, so we're going to put negative 2.5 squared, okay, plus 5x. So you're going to do plus 5 times negative 2.5 plus 6. Okay, and we're going to actually break this down, and again you could just put it into your calculator, but I'm going to write out the answers so everyone can see that. Okay, and 5 times negative 2.5, so negative 12.5 plus 6. Okay, a lot of teachers are not too picky here. Okay, so if you want, you can just write your final answer. Okay, this is just to make sure everyone understands about the signs. Okay, so this is 6.25 positive minus 12.5 and then plus 6. Okay, so you should be getting negative 0.25. This is the y point of the vertex. Okay, so my vertex, I'm just going to put v here, is negative 2.5 and negative 0.25. Okay, does everyone see that? Okay, and again, I noticed that I do have decimals here, which is okay. Even when you graph it out, it's going to be like more of a sketch. Okay, so I'm going to take this off. Okay, we're going to just try sketching out our graph over here. Again, make sure you are using graph paper at home to make sure that the parabola is very accurate. Okay, so you're just going to make your Cartesian plane like this. Okay, what I want to actually graph out is going to be my x-intercepts, which is negative 3 and negative 2. Okay, so I'm just graphing out the intercepts that we solved for. And the third thing I need to graph is basically the vertex. Okay, so the vertex is at negative. This is negative 2, negative 3. So it's negative 2.5. Oh, we'll go this way actually. So negative 2.5 and negative 0.25. So it's something like this actually, okay? Because this is the x and the y point of the vertex. So my parabola is just like opening upwards and it looks something like this. So again, my drawing here is just a sketch. Yours should be very accurate, okay, when you're doing it on graph paper. Alright, if you're actually looking at the original equation, you notice there's no negative sign in front of the x squared. And that actually does indicate that the parabola is opening upwards. Okay, so are there any questions? Okay, so one more time, all we did was we had our equation here, which was a simple trinomial, and then we made sure that we factored it out to find the x-intercepts, and right after we did that, we found the x point of the vertex by adding the intercepts together, dividing it by 2. That's the x point of the vertex, and to find the y point of the vertex, we took our answer, which was the x point, and we plugged it back into the original equation. And that's actually how you solve for the vertex. And this is one of the methods for solving for the vertex. You should know how to do this method. And there will be another method that we go through afterwards, which is known as completing the square. And both of these methods give you the vertex right away for the parabola. So there, it is very effective. Okay, so with that, let's try one more example here. All right, so I'm going to take this off. We're going to try a simple example. So again, it's just so everyone can grasp the concept, okay? So let's try this one. So it's y equals x squared plus 9x, okay? And here, because there are only two terms, it's not a difference of squares because there's no negative sign in between the two terms. And I can see by looking at them that they are not perfect squares either, okay? So I'm going to take out a common factor. I'm going to take out the x. And what I'm left with is x plus 9, okay? From the 9x, I'm taking the x outside. So inside the brackets, it should just be 9, okay? I'm going to make it equal to 0 as an equation. And I'm going to solve for my x-intercepts, okay? So in this case, x is equal to 0. And if you look at the other term, I'm going to do x plus 9, which is equal to 0. Again, you notice that the 9 is positive on the left side. When you take it to the right side, it's going to be negative. So x equals negative 9. Okay, so these are my two x-intercepts right here. Okay. What we're going to do is find the vertex. So let's write vertex here. And I always write it like this, okay? So we're going to put Vx equals, and the x point of the vertex, you're just going to add the intercepts together and divide it by 2. Okay, so we're going to do 0 plus negative 9 and divide it by 2, okay? So we can see that it is 4.5 negative. I'm going to just keep that as the decimal. Okay, so this is how you're solving for the x point of the vertex. When you're solving for the y point, I'm going to plug it back into the original equation here. The original equation is again the x squared plus 9x, okay? And just always plug it into that equation. This is in the standard form here, okay? And that way you don't mess up any of the signs, all right? So I'm going to put negative 4.5 squared plus 9 times negative 4.5. Okay, so again, we're just going to put this into our calculator. So 20.25. Okay, and then 9 times 4.5, which is minus 40.5. Okay, does everyone see that? So we're basically multiplying it. I just plugged it into the original equation here. Okay, and we're going to subtract the two numbers. And we are getting also the same thing. So negative 20.25. Okay, and so this is going to be our vertex. It's negative 4.5, negative 20.25. Alright, and I can see I only need 3 points in order to graph out a sketch of the parabola, because that is sufficient. 3 points is sufficient here. I just need the vertex, which is the most important point on the parabola, and I need the x-intercepts, okay? So let's take this out. So I'm going to just write out our intercepts here. We got x equals 0. Okay, and x equals negative 9. Okay, and that way we can just make a really short sketch right here, okay, on the side. So let's make our Cartesian plane. So I can see basically for the vertex, the y point of the vertex sometimes is actually really big or really small. You can just take a scale, okay, when you are sketching it out. It might not be as accurate, but that's all right, okay? So we're going to do 0 and negative 9, okay? So negative 9 is going to be right here. So first off, I'm just going to start with my x-intercept. So 0 and negative 9, okay? And again, if you're looking at basically the original equation, there's no negative sign in front of the x squared. The parabola should be opening upwards. If there is a negative sign in front of the x squared, the parabola will open downwards, okay? So I have my x-intercepts here. Let's take a scale. So we are at negative 4 and this is negative 5, okay? So let's go by 10. Oh, let's go by 5s, okay? So negative 5, negative 10, negative 15, negative 20. Okay, because it's at negative 20.25, okay? So that's not too bad. So 4.5, negative 20.25, okay? And even if you weren't sure about whether the parabola is opening up or down, I have to connect the 3 dots together so I can see that the parabola is opening upwards indeed. Okay, I'm just gonna connect these 3 dots together. Okay, in this case, you notice that the parabola does look like it's wider, okay? It doesn't have to be the case. Again, what I'm doing on the board here is just a sketch. Okay, when you do it on graph paper, you'll notice it's very accurate. There actually is no stretch or compression here. The graph should not look wider or like skinnier at this point in time. Okay, and we will be going through a little more about the transformation of the quadratics within the next few videos as well. And that way you know what you are looking for when you're graphing out the quadratic. All right, okay. So that looks good. So if there are no questions, that brings this video to an end. Make sure you're doing a lot of practice questions again in terms of factoring and finding the x-intercepts. And we are using this method to find the vertex of the parabola. Okay, make sure you're doing the Vx and the Vy separately. Okay, when you're looking for the value of Vy for the vertex, make sure you are plugging it into the original equation to get that answer. And again, all you need is these 3 points. I need the vertex and the 2 x-intercepts, which is, as you can see, sufficient to graph out the parabola. Okay, so thank you for watching. Please make sure you like, share, and subscribe to the channel, and I will see everyone next time. Thanks, bye.